I would like to address very fundamental issues regarding the manner in which very preliminary concepts be exposed before the students, especially in electronics engineering. As we may be aware that electronics engineering is highest proliferated branch with maximum number of students, and unfortunately I hope that most of us will agree that is least understood by the students because of lack of visualization and undue complexity of contents on their own, as well as the manner in which those are brought forward. Especially for our generation, we can say that electronics engineering for us is semiconductor technology. The vacuum tube now is a part of history, and let us not spend any time on anything related to that. But semiconductor technology is considered to be beginning of electronics, and you might be aware that nowadays, even though there is CMOS, NMOS, PMOS or something else, but still one will surely find that the beginning of electronics engineering is there with a PN junction diode and a bi-junction transistor BJT. What happens is, this is my frank submission, that there is a need for revolutionary transformation in the manner in which the students at the early stage are exposed to the contents of electronics engineering. There is a cascading effect because of non-understanding of fundamentals, not because that a teacher is unable to explain, not because that the student is unable to grasp, but because these are very difficult in reality to be understood thoroughly if an attempt is made to understand. A mediocre never makes an attempt, but a serious student, most of you must have been serious even in your student days, will that serious student finds that he is unable to grasp. For example, prior to coming to electronics or semiconductor technology, we are well exposed to some electric circuits. What is peculiarity of electric circuits? Peculiarity of electric circuits is that way if we decide to probe everything which comes across us from a student point of view, functioning of even a resistor is difficult to be explained, because the voltage is called as electromotive force. Then when voltage is applied to two ends of the wire, why electrons do not accelerate? Then they do accelerate, then there are collisions in which they lose some, what we can say, energy, and because of that there is laminar or steady flow, that with that way it can be explained. So even functioning of resistor is also difficult, functioning of even voltage source, what is voltage, all these are very difficult things to be explained if we decide to explain it to a very inquisitive mind. For an average mind, it does not make any difference. But still we can say that you will not say that an electrical engineer complaining about understanding of resistor. That is because after certain time, either the understanding of concepts of human being itself is very complex phenomenon. An individual tries to understand to his or her level best, but after certain time he understands it by default. What is understanding by default? Understanding by default means it is just like a Gödel's phenomenon, Gödel's theory. Once it is listened repeatedly, even if it is a false statement, an individual believes it to be correct. Like that, when some peculiar typical fixed sentences are bombarded on an individual in any scientific field, after certain time the people gets transformed into such a state where they feel that they are understanding it. It is called a pseudo understanding phenomenon. So, in electrical engineering, in electrical circuits, the concepts like voltage and current, which includes charge, what I claim is, I will never claim that every electrical engineering student is having perfect understanding of voltage and current concepts, but I will definitely say that every electronics engineer has got a pseudo and perfect pseudo understanding. Perfect pseudo is a paradox. I am just using the opposite terms with each other. An electrical engineer is having perfect pseudo understanding so that he is able to solve the things in electric circuits like Kirchhoff's laws, voltage law or mesh law, nodal law, current law, like Thevenin's theorem. Means in all those aspects he gets a good going after certain time by using some thumb rules like that. But that does not become a case in electronics engineering when we start with a diode. When we start with diode, unfortunately, I do not know what is the reason and for what purpose we are following all these things. The diode, I would like to appeal every individual to listen with full concentration till the end, because it can't be understood in parts. So, there is a fundamental flaw in exposing the students about diode and transistor. We try to teach them by using what is called as structural model. What is a structural model? The structure model is, we explain them p-type semiconductor, then energy levels, Fermi level, n-type semiconductor, then we show their junction. In fact, if see, the purpose of this course is not to teach you something which I am very much sure that everybody knows, but is to address the critical points in electronics engineering curriculum from students' point of view. And this, what I am organizing the session, reflects my own confusions during my student age 3 decades back. So, with those things in mind, I am trying my level best to suggest some off the track ways with which the students' understanding can be brought on track. So, what we do is we show them a diode, we draw like this and we say P here and N here. To be precise, it is a cut section, it is not 3D. So, how actual diode, which is a physical entity which has to be of 3 dimensions, where is the P part, where is the N part, are they just like these 2 dusters coming like this, or some kind of other arrangement, how the leads are drawn, that also we are unable to explain. And then what is diffusion, then potential barrier, then when voltage is applied to diode, see, when we apply some voltage to diode, we also put some resistance, sometimes we may put, sometimes we may not put, that is not so significant right now. And then we try to explain how diode works, why current increases in a non-linear manner by trying to give some examples of potential barrier, then the carriers are either pushed aside, attracted, then the concept of hole. Actually, it is very difficult that whole conduction of particles in electrons in valence band is actually journey of holes, movement of holes. Otherwise, from student's point of view, the current because of holes is something which he is unable to understand how it is different than current because of electrons, because both are in reverse direction. So, current because of electrons, and why the concept of hole is not there in a conductor. So, that is, we try at the initial stage, we try to explain something by using structural model which is just beyond his scope of understanding, and moreover it is not necessary also. Everything cannot be taught at the beginning. Therefore, any attempt to explain the diode current, any attempt to explain the working of diode by the P type and N type semiconductor, their properties, their model, Fermi energy levels, and all those, diffusion current, potential barrier, is just impossible. All have, there is a miserable failure of all these kinds of techniques, and I am sure that no student will be able to understand working of diode by using such kind of explanation. Then what is needed? That is called a behavioral model. So, what I will explain very appropriately why this behavioral model is necessary. Teaching learning process, understanding process is interdependent. To understand some particular thing, say B, you must understand something like A. Then to understand C, you need to understand B. But how you will understand A? How will you understand A? Is it that by birth you contain something which is A within you? No. To understand A, you also need to something else, and that chain is infinite. That chain is infinite, and that chain may be cyclic also. So, understanding means knowing something enables you to understand some other thing, and so on. But the first thing which requires to be known can't be understood. So, unless we assume somewhere, we can't progress. We can't have any kind of understanding concepts. So, the question is what to assume? What to assume? We assume something, build our further understanding long journey, and once we are able to understand at a longer stretch, then human being abilities are very peculiar. Then based on, it is just like some kind of Lenz's law structure in a reverse sense. Means I assume A, based on that I go on understanding B, C, D, E up to Z, and when I understand Z, that time I automatically start understanding something about A which I had assumed initially. So, it is a very peculiar selection to start from which point, that is the base, and the students must be told that right now you do not question, right now you do not question, right now you assume, based on that assumption build the entire multi-story building, and then we can further deliberate. Means now I would like to give you simple examples. When colors are taught for children, we never tell them that it is having some wavelength, that is red, then blue, then green. We do not tell them, we show them pieces of colors. This is red. That time we do not tell the concept of wavelength. If you decide to tell that, then you will be confusing the student at an early stage. Like that, if ever diode and transistor is to be understood by a student, then never tell the students how they function. Simply, so just like color, this is red, and then student makes a proper programming of his mind so that he is able to understand what is red when he sees some other piece. So, like that, never tell the students about the diode construction and all these things. Then what to tell? Now, voltage and current, there is a perfect pseudo understanding with student. Voltage is something which is to be taken between 2 points, and current is something which is across the path, that is known. So, based on that, diode is to be considered as a 2-terminal device. Diode is never tell the construction of diode. And now in the latter part of the lecture you will realize that transistor is something, if an attempt is to be made of explaining transistor using diodes, nobody understands. 2 diodes connected together, or NPN, and then early effect, then the recombination of carriers, everything means what I say, I am not ruling it out. What I am stressing upon is, there is no need to begin with that. What is needed is, you explain them in such a manner where they get a good workable knowledge, and based on that, let all this discussion of structural aspects, actual working, you introduce at a later stage, so that those who are interested may pursue, those who are not so interested or those who are not so capable may drop that. If you introduce this in the beginning, then this is the reason for electronics engineering students lack in interest in studies. So, what I strongly argue is, never expose them to diode structure, but to expose them with what? Let there be a very clear cut concept that this is symbol of diode, P and N, it is distinct and not interchangeable. These means just like a resistor, diode is a 2-terminal device, but for resistor both terminals are identical, for diode both terminals are not identical, both terminals are specific. So, you just tell them diode is a 2-terminal device, and then what is a resistor? Resistor is a device which is 0th order linear device. Means what we mean by 0th order linear device? Where voltage across the resistor and current through the resistor at any given point Vt and It are linear to each other. Capacitor is a first order linear device where current and time derivative of voltage are linear. Like that, what is diode? Diode is a 0th order non-linear device. So, in my further sessions, I will explain simple things, voltage, current you have pseudo understanding, then diode, resistance, capacitance and inductance we do not require much, but we can use it. But to be very precise, diode, resistor, capacitor, everything in electronics is covered in these 3 things: voltage, current, diode, resistor and capacitor. Vivek Pawar of Sankalp has described it as Panch Mahabhutas of electronics: voltage, current, diode, resistor and capacitor. So, diode is 0th order non-linear device, means there is an relationship there is an instantaneous relationship between voltage and current, Vt and It. For resistor it is linear, for diode it is non-linear. So, then diode equation is there, which you assume, which you do not question right now. ID is current through diode is presumed to be from P to N, that is ID, and Vd is voltage across diode measured from point P with respect to point N. So, this is Vd, this is Id, and it will change depending on time. So, Id at any given point, this T we will remove, but I am telling right now because to stress that diode is a 0th order device, means there is a relationship between current through the diode and voltage across the diode instantaneously. So, Vd is Idt is equal to Is some constant, we right now do not, it is reverse saturation current, but right now some constant into e raised to something minus 1, and in that exponent we have got voltage, it is Vd upon eta Vt, this is something related to temperature and all that, but for us what we can say is Idt is equal to some constant C1 into e raised to some other constant C2 Vdt minus 1. Then since it is, we now know that it is in 0th order system, T we may remove, so that voltage across current through diode is equal to constant into e raised to another constant Vd minus 1. So, this is something which we should tell the students, yes, this is diode, this is diode. Now, when diode was taught maybe 50 years back, that time computational luxury was not there. Computational luxury was not there, and it was not possible for students to draw the characteristic of diode using this equation. Now, everything is equipped with computational capacity. You have mobiles, smartphones, you can have small programs. So, we may take their help. So, what we tell the students, yes, now there is no need for you to think much right now. You just understand this thing, that this particular device is having this particular relationship, that is behavioral model. Diode behaves like this, just like a resistor where it is voltage across, that is Vr, current through is IR, and we say that IR is equal to Vr upon R, some constant I say C3 into Vr. So, what is behavioral model of resistor? Resistor is a device where terminals are interchangeable, immaterial. Here it is not interchangeable. Resistor is device where current is linearly dependent upon voltage with some constant. Here current is dependent upon voltage in some non-linear manner, but for a given diode it is fixed. For a given resistance this is fixed. For a given diode the terms C1 and C2 are fixed. So, if this is told clearly, then what happens is, I will certainly say that I will take few examples, and you must have also observed that the students are unable to answer because they do work with something like 0.7 for silicon diode and 0.3 for germanium diode. They do not understand, they try to connect something which they have heard and apply it in a wrong manner. What the reasons thereof are very simple. So, now what I propose is, that suppose that now students are very much expert in programming, maybe Python, MATLAB, C, like that. Then the things should be taught them in such a manner that just like assume something A, and based on that you should be able to explain them how to go for B. This is our purpose. So, what I mean is every student who knows very preliminary programming and common sense, he is having tool in his mind, he is having a good mathematical tool in his hand. So, using that he must be able to find the answers. So, voltage is known to student, current is known to student, voltage source, ideal voltage source is again pseudo understood. So, voltage source, resistance and a diode. So, now I will why it is important, because if you do not make the students aware and understand these simple things, then very complex things students, we are just bombarding on them and they are carrying it with them without any understanding. So, how that understanding of a student is pseudo or not pseudo, it is wrong, that I will explain to you with a very simple concept. You may conduct a survey, maybe immediately after this lecture, using some kind of Google form with your students, that let there be a 1 volt or not 1 volt, a good 1.5 volt by a battery cell which students can bring. Then let there be a silicon diode like this, let the circuit be like this, and let there be a digital voltmeter. DVM also, now students have good multimeter, let there be a voltmeter, a good quality voltmeter I am stressing, and they connect, it should be connected like this. And you ask students what will be reading of the voltmeter, and you will certainly find that 90% students will give a wrong answer, and the wrong answer would be 0.8 volts. 90% students will give wrong answer and the wrong answer is 0.8 volts. This is because of the way in which the diode is explained is entirely wrong. We unnecessarily go for forward bias, cut-in voltage and 0.7 attached to it. Means now very few students will be able to draw it, but we do not want that this technique to be restricted to only few. We must explain in such a manner that a person with good common sense, reasonable programming ability must be able to find out the answer. Why this happens? Because when a diode is there, a concept which is wrongly built in students is that it eats 0.7 volts. Diode eats 0.7 volts across it. So, 1 point from the other side, diode eating a 0.7, 0.8 at the output. Now, if we go on asking the student what will happen if 1 volt is here, then he will say 0.3. If you ask what will happen if you say 0.7 volt is there, student answer 0. And then if you ask what will happen if 0.2 volt is there, then some smart student out of those may start, oh, 0.2, then 0.7 is eaten up, then minus 0.5. No, that people will not answer. Then what will be the wrong logic, accidentally correct? They say that diode eats 0.7 volts. But eats means what? At least that should be available. If not, then from where it can eat? So, they will say if it is 0.7 here, yes, then the diode will eat all 0.7, there will be 0. If it is 0.6, still it will be 0. If it is 0.5, it will be 0. So, there may be answer like this. And then if you ask, if I connect a reverse battery like this, here almost everybody will fail, and minus or this reverse battery 10 volts, or if you show simple voltage source, then it is minus 10 volts. and like this. And then there is a big question, many will be confused here, and most will answer 0, because it is reverse binary blocks. So, in forward, so what is the wrong notion? In forward bias it eats 0.7, in reverse bias it blocks all or eats all. So, diode is something which is eating up 0.7 in forward bias and eating all in reverse bias, where it is not the case at all. This is because the diode is explained to the students in a wrong manner, in which they neither understand nor able to apply how diode works. So, now let us try to have the concepts of diode and resistor circuit, and we ask the students, see, as I again repeat that the purpose of this lecture is pedagogical aspects, in which I am trying to give examples which are to be taken to the students from understanding point of view, and answers must be sought. So, if a simple question is to be posed before the students, a 5-volt voltage source, a 100 ohm resistance and a diode, right, and the question is find out the current in the circuit. Once current is found, everything else gets finalized. I again repeat that the purpose of this lecture is pedagogy, not something asking you and seeking answers from you. So, now how this theme should be introduced to the students, right? So, this example contains 3 elements and others as interconnecting links, which are assumed to be in fact actually this is also what is an interconnecting link, it is like a superconductor, but right now let us not focus on that. So, this is a voltage source which always maintains 5 volts across it. Right now we are not considering infinite load. So, let us restrict ourselves the discussion. So, let it be an ideal source 5 volts, 100 ohm resistor and a diode. This is how to address the problem, how student is supposed to find the answer for this. Now, there are many ways with which we can approach. The first way using equations, second way using graph, third way using numerical methods. Actually, maybe when you might have been students or few decades back, when there was not such proliferation of MATLAB and all those, Fortran programming was there, that time numerical computational techniques was a subject, but it was used majorly in civil and mechanical engineering. In electronics engineering, hardly you might be remembering that you have solved this example by numerical computation techniques. So, that also we can solve. What I say is, do not use Proteus or something which gives you direct answer. You make the students to find the answer. How? So, just like when going for derivatives, if we are stuck up somewhere, then we go by first principles, that is f dash x is equal to f of x, f dash x is equal to f of x plus h minus f x upon h, as h tends to 0. Actually, I was stumbling at f of x few seconds ago. This is because actually this, when we go for some kind of discrete time signal processing, I have a new conviction about it. The derivative of f of x plus f dash x is f of, it is a small deviation, but I think it is a worthwhile deviation. F dash x is equal to f of x plus h minus fx upon h. What I say, what my perception is, it is not so perfect or so scientific. What I would like to suggest is, it should be like this. So, I got stumbled what to tell, whether I should tell what I think or whether I should tell which is widely known. My logic is f of x minus f of x minus h upon h as h tends to 0, because it is something, when you are at x, it is something which is coming ahead, and why we should go for coming ahead? It is something which has happened. So, this is, anyway, that is not our subject matter right now. So, using this you can find derivative. Like that, you go by simple characteristics of the devices. So, what are the characteristics of the devices? First is voltage source. What is characteristic of a constant voltage source? It will maintain always 5 volts. You know Kirchhoff's law. So, Kirchhoff's law will give you that voltage across voltage source is voltage across resistor plus voltage across diode. So, I repeat that, don't be under impression that I am telling simple things. I am explaining the way with which these things be unfolded before the students, so that everybody understands. When we go for inclusive education, we should ensure that at least beginning things are understood by everybody, then let everybody pick up depending upon capabilities. Don't tell beginning things in complex language, so that many are driven out of the system. So, what we do, this is point A, point B and point C. Point A, point B and point C I have drawn deliberately different names, so that there is no confusion. So, VAC is equal to VAB plus VBC, right? What is you should tell this, means what our journey should be from it should be what we want to find out. What is the question? The question is to find I, which is completely unknown. So, we should travel towards unknown by knowing something which we completely know. So, Kirchhoff's law we know, VAC is equal to VAB plus VBC. What is VAC? As it is an ideal voltage source, phi u is equal to, what is VAB? VAB is voltage across resistor plus this voltage across diode. Voltage across resistor plus voltage across diode. Up to that, there should not be any problem for any student. Now, what we are expected to find out? The question we are asked to find out current. We are asked to find out current I in the circuit. So, that also we can find. I can explain it, the method with which we can find the current, but I will rephrase the question, because when current is known, everything else is known, but I deliberately rephrase the question so that it is somewhat simpler. That the question is, find out voltage across diode is the question. So, the question is, find out this voltage is the question. Find out this voltage is the question. So, it is somewhat more simple. It is somewhat more simple. Then how? See, according to me, I have never came across any such method by which we can find out the diode voltage in a given circuit. Diode equation is difficult, no doubt, but once why this exponential expression was considered difficult? maybe when it was devised 6-7 decades back, that time the computation was not easy. So, because of that, listen very carefully, why you, according to my belief, I would be happy if I am proven wrong, you have not came across such method of finding voltage across diode in the diode circuit. You might have come by a load line, but that is not, that is a way, but we must have answered with this, because why? We know what is diode, what is diode means, how diode, what is the working of diode, we know what is the working of resistor. So, phi u is equal to VR plus Vd, that is something which we know. Then obviously, by simple rearrangement of the terms, we can say Vd is equal to phi u minus Vr. So, this is the step, means just like students very, it's a, after all every student is a child. So, when he becomes happy, what is we found out? Vd. When it comes on left hand side and everything comes on right hand side, he is thinks that yes, I am on right track. So, Vd is equal to phi u minus Vr, and we need to go further. Then how we should go further? Now, voltage source is 5 volts always, that we know. What we are having is that this is resistor Vr, current is IR, this is diode, voltage is Vd, this voltage is Vr, and this current is Id, right? And we know resistor is a two-terminal device, diode is a two-terminal device, both are 0th order devices, means for each of these devices there is a relationship between voltage and current. Voltage across diode, voltage across resistor is directly proportional to current through the resistor, or current through the resistor is directly proportional to the voltage in a linear manner, whereas current through the diode is depending upon voltage across the diode in a non-linear manner, right. So, if that is told and you give some technique of programming, everybody would be able to find the answer. I will explain that we must tell the working of diode in this manner. So, how? Now, fortunately for this circuit, what we can have? IR and ID, since it is series circuit, you should explain IR is equal to ID, let that be equal to I. Let us assume that it is I. IR is equal to ID is equal to I. Then what is VR? What is VR? VR is equal to 100 into IR or I. So, VR is equal to 100 I. I think that there is no confusion. See, voltage across resistor and current through resistor, there is some relationship given by V equal to IR or I equal to V upon R. I equal to V upon R. Like that, for diode, why we should be allergic? What is the diode relationship? Diode relationship is I is equal to ID is equal to IS e raised to Vd upon eta Vt minus 1. Let it be so, there is no harm. So, what we can do? This is one constant. So, this we have changed in a simple manner. What is that? ID is equal to C1 e raised to C2 Vd minus 1. So, this is the relationship between I and V across the diode. So, we know voltage source is fixed for any current, voltage is fixed. What is the relationship of voltage, ideal voltage source? Irrespective of current, voltage is 5 volts. What is relationship for resistor? Either VR equal to 100 IR, IR being ID, IR being I, because IR equal to ID equal to I, or you can write alternatively I is equal to VR upon 100. I is equal to VR upon 100, and here what is that? ID is equal to, now we can start working for final solution. What is ID? ID, since IR equal to ID equal to I, you can write second equation, I is equal to C1 e raised to C2 VD, C2 VD minus 1. I is equal to VR upon 100, and VD equal to, what we want to find? We want to find VD. VD equal to 5 minus VR. VD equal to 5 minus VR. So, I think that even though, see, this one, now there may be many takers for this, we will say though it is too clumsy, but at least for a common sense student, this 5 everybody knows, this equation everybody knows, this equation everybody can understand. It is some equation, this is some equation, it will happen this way. Rather than Fermi level, potential barrier and cut-in voltage, this is something which a student can understand by practice. Now, how to proceed further? It now reduces to a high school scholarship, or since exponential is coming, NTS scholarship level problem. It is very simple, everything is well defined. In conventional diode understanding, that is not defined at all. So, now how we can proceed further? We are having 3 equations, 1, 2 and 3. So, we can put I will explain it by all possible methods. So, now VD we have, VD is equal to 5 minus VR. What is VR? VR is 100I. We go it by different methods. So, which method suits for individual will depend upon that individual and his liking. So, VD is, I think this equation everybody understood, means when I say everybody understood, please do not misunderstand it, I am checking your understanding. When I say in the lecture, in this pedagogical technical lecture, that everybody understood, means this equation is so simple that every student which you will be teaching will understand that VD is equal to 5 minus VR, I is equal to VR upon 100, because that is the characteristic of the resistor, and I also has to be equal to C1 e raised to VD upon C1 e raised to C2 VD minus 1, because it is diode equation. So, using all these 3, what is the question? To find VD. So, VD is equal to 5 minus 100I, 5 minus 100I, and what is I? Given there. So, VD is equal to C1 into e raised to, because sorry, just a minute, I would like to change, I have forgotten 5, VD is equal to 5 as it is, minus 100 C1 e raised to C2 VD minus 1. So, ultimately we got it. Why? Because then you will say how, what you are telling that I should get with VD unknown on left hand side and everything known on the right hand side. How you are claiming that you got the answer? I say that we have got it because except VD everything is known in the equation. Except VD everything is known in this equation. 5 is known, 100 is known, this constant is known, this constant is known, this is known, this is universal constant. Then how we will solve the, what would be the answer? How we will claim that, how to get the answer now? Here numerical techniques help. Is it? I think This everybody understands, every student should understand. This every student should understand. This is something which is not understood, it is something we start with. What is diode? Diode is a device which is having this characteristic. So, this and this everybody knows now. Now the question is how to solve. How will you solve? Is there any, what we can say, closed form expression? Is there any standard solution for this question? Can there be a closed form mathematical expression for this using some logarithms and all these things? That becomes debatable, and also this is not the requirement of masses. Nobody is too keen in this. Then what we should go for? So, this diode resistor circuit is a classical problem for numerical computational methods. How you will solve? Common sense, voltage will not be negative, VD will not be negative, voltage will not be beyond 5 volts, voltage will not be beyond 5 volts. So, VD will not be negative, so it will not be below 0, it will not go above 5 volts, it will not go above 5 volts. Now, how to start? You can, I hope that this is something which means now this equation will be satisfied by a single value of VD. For a single value of VD, this equation will be satisfied. For all the values of VD, it will not be satisfied. Then, if you are unable to find for what value it will be satisfied by closed form expression, the students in today's age have come from CET, in which they are not supposed to find the answer, they are supposed to check which of the 4 options is correct. So, we go this for numerical method. Then what we do? By common sense, voltage will not be below 0, by common sense voltage will not be above 5. So, what is the starting point with which you can start? Obviously 2.5. Start it with 2.5 and go by successive approximation method, just like ADC, DAC. In ADC, you have successive approximation method. So, like that I am just explaining, it is totally unique. You will find that students, once they are exposed, they will understand appropriately, because that is required in further understanding of transistor, because diode circuit understanding I will explain load line also, but this is I am explaining separately because this is something which I am sure that nobody would have come across. So, how we will start? You assume that, so for what value of VDT should be satisfied, that we have to find out. So, LHS is equal to VD, so you assume it to be 2.5 and find RHS. You can write a simple program through MATLAB, Python, C, what it may be, or there may be you can write it using it calculator also, if it is scientific calculator. Then RHS. So, what you will find that for 2.5, for LHS VD equal to 2.5, if RHS also comes as 2.5, what does it mean? Yes, that is the answer. VD is 2.5. It will not come, but I am just saying for the sake of statement. If RHS comes as 2.5 volts, it is the answer. Then what will happen? RHS will be, suppose it comes as 4, let us say 4. RHS comes as 4. Then what is the conclusion? That our answer is wrong. 2.5 is wrong answer. Actually, if you want to go fast, you can tell that the answer is somewhere near 0.7, 0.8, and still you can go in a faster manner. But why we should bias for 0.7, 0.8? We should not bias. So, 2.5 is good thing between 5 and 0. Then you get an answer which is 4, which is not equal to LHS. LHS we start with 2.5, RHS is not equal to LHS. Then you start with VD. How will you, means we should make the students to learn. How we can make them to learn? We make them to start with VD equal to next value. What value they should choose? I said it will be between 0 to 5, we start with 2.5, then successive approximation. Now you choose between and that is your choice, between 2.5 to 5, or you can choose between 2.5 to 0. You use common sense and choose 1.25. Let RHS, let VD be equal to 1.25, that is equal to LHS. Then find RHS. I think this everybody can find out, it is very simple. Find RHS, what that would be. Find RHS, what that would be. After finding RHS, suppose if you find RHS as 2, which is not equal to LHS. So, this is a, so here it was not there, so it is a wrong answer. This is also a wrong answer now. 1.25 is also wrong. Then what you should choose? Between 1.25 to 2.5, half of that, or between 1.25 to 0, half of that. You know that it is near 0.7, so you will choose 0.625. So, let VD be equal to 0.625, that is equal to LHS. What is RHS? You will find, and that RHS will be, not so much away, maybe say, maybe I am just guesswork, 0.75. So, closer but not there. Then you can have various methods, or here I made some small mistake here. So, it is, if let it be, you can go by half range of that, or there can be alternative way. What alternative way can be? Suppose that it is 2.5, for that suppose if it comes as 1, then next point you can start with between 2.5 and 1 you can start with, between these two, like that, and somehow you can come to this. So, ultimately you will find that once 0.625 is 0.75. Then suppose if you go for 0.65, so ultimately you will get a table. It is very, means it is, this is something which is tedious, no doubt that what students are supposed to do is tedious, repeated, but now they have tool with them. They can write a program simply to start with, and they can start from right from 0 in a step of 0.01 and develop a program. Simply what they can do, you can have this, what I was telling, that successive approximation, this is a very old logic. Why? Because computational power was less. Now what you can say, now you are having so fast computers that there is no work for the computers. So, ultimately you assume something, you get something. So, what you can have? You can write a program, you can start with VD equal to, how you can write a program, LHS equal to VD 0.01, 0.02, 0.03, you can have it, or instead of this you can also have between, you can go by simple steps. What I was telling, that fast logic is not also necessary. Simply LHS VD 0, 1, 2, 3, 4, 5 and RHS you find. So, what you will find for 0, suppose if we start with VD equal to 0, what is RH? If VD is 0, what happens? If VD is 0, that goes on the other side and you get some value of RHS. So let us say that I am just guesswork, RHS is 3. Suppose if for this one, this RHS is 0.2, for this it is 0.7, like this. So LHS 0, RHS 3, LHS 1, RHS 0.2. So they will not match except for one value. But now where we should go deep? The mismatch is that for 0 LHS, RHS is 3, and for 1 LHS, RHS is 0.2. Means for 0 LHS, RHS was more, for 1 LHS, RHS is less. So this you need not go for. So how you should probe now? From 0 you can have further 0, then 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9 and 1. So this you can have, and this you can say for 0 it was 3, for 0.1 it was 2.5, for 0.2 it is 2, for 0.3 it is 1.5, for these are just some values, 0.1, for 0.5 it is 0.9, for 0.6 it is 0.8, and for 0.7 it is 0.66, just I am giving the value, and then for 0.8 it is 0.5, for 0.9 it is 0.4, and for 1 I have said 0.2, just for the sake of example. So what do we get? So how you come close? It's mismatch. Up to this 0, this is more, 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 this is less. So it lies between 0.6 and 0.7. So like that you may ask a student to find the value up to 3 decimal places correctly. So that will be the answer. And then that you can change by changing. Now you can rearrange the program. This you can change, this you can change, this you can change, this you can change. This is silicon diode. For genuine diode, there will be different equation. Different equation means what is difference there? C1 and C2 will be different. C1 and C2 will be different. So this you can get. So what is this? This is the solving for an equation where a linear device and non-linear device are connected together to a voltage source. Means voltage source is fixed, one linear device, one non-linear device, those have been connected. Now all this discussion is explained now in a graphical manner. I hope that most of you must be knowing it, that is load line. It must have been dealt with also, but somehow the stress which one should give on load line is not much, and unnecessary stress is there on explaining diode. So what is the crux, what is the takeaway for this session? I will explain diode load line simply, and then we will end. What is the crux of this session? Crux of this session is never explain, never try to have a futile attempt of explaining how diode works. Simply tell them what is VI characteristic of diode and how that is. So now this is very simple. Diode load line everybody knows, many must have also taught, but many might not have also. So this is something which one should have, that is, this is VD and this is ID. So VD and ID, voltage and diode, voltage and current through diode. So it is something like this, and it is very less on this side. Unfortunately, the cut-in voltage of diode, many say that it is the point from which current starts rising very rapidly. That very concept is irrelevant. Very rapidly, something less and something more, we can't have any threshold as such. So this is VI characteristic of diode, which is very clear, VD and ID. So this is VD, this is ID, VD, ID. This is VI voltage and current which will flow in the circuit as dictated by the diode. But diode is not alone in the circuit. There is voltage source and there is resistor also. Now, we can have phi u is equal to VR plus VD. Phi u is equal to VR plus VD. That is very clear. So, what is VR? VR is equal to phi u minus VD, and IR is equal to ID. IR is equal to ID. So, we can plot VR IR characteristic here. We can also plot VR IR characteristic also here. ID is same as IR. ID is same as IR. Now, how VR IR characteristic is plotted? When we have plotted VD on this line axis, ID and IR being same, actually diode load line explaining is a art, because that reverse resistor why it comes, that is need to be explained. So, VD ID we can very easy, VD ID, this must be the relationship. Now, IR is ID because of series circuit, so IR also is here, IR is ID, no need of separate one. Now, how VR is to be plotted? How VR is to be plotted? Because we can't plot on this line we have plotted VD, on this line we have plotted VD. Then with respect to VD, what would be IR characteristic as required by the resistor? Listen very carefully. This is the diode load line is to be explained to the student so that every student understands what it is. So, as this voltage across diode and current through diode, this everybody understands. Now, what we are expected to go for? We are expected to go for plotting how resist. So, VD ID characteristic means the diode wants VD ID in this circuit to be in this manner. This is diode's condition. So, diode characteristic means anything of this is possible which is dictated by other considerations. Characteristic does not give the answer. Characteristic restricts the domain of two variables on a single non-linear curve. Now, what exactly will reside is we should plot VD and IR or ID as governed by resistor. How it is governed? Phi u is equal to VR plus VD. Phi u is equal to VR plus VD. What is VR? VR is equal to 100 IR plus VD. Is it clear? Phi u is equal to VR plus VD. Phi u is equal to 100 IR plus VD, and as it is series circuit, phi u is equal to 100 ID plus VD. So, actually it is two simultaneous equations to be solved. One is non-linear equation which we have plotted, because this is to be just plotted by common sense, by knowing something, and the second equation is this equation, that is phi u is equal to 100 ID plus VD. It is a linear equation, it is a straight line. This equation, why this equation has come? This equation has come because of resistor, that phi u is equal to VR plus VD, and we have used resistance. Here we were not interested in resistance, it is diode property. Now, phi is equal to VR plus VD, VR equal to 100 I is resistance property, and as it is series circuit, I put phi is equal to 100 ID plus VD. Then it is a straight line. So, how we can plot the straight line? If I take VD equal to 0, if I take VD is equal to 0, in that case ID would be equal to VD 0, ID is equal to phi upon 100, that is 0.5. This I am taking as 0.5, and I think that not so 0.5, And if I take ID as 0, VD is 5. And then this is the line. This is the line. So, this resistance requires certain restriction on voltage across it and current through it. When resistance requires certain restriction on voltage across it and current through it means current through diode. So, resistance requires certain restriction on diode current and resistor voltage. But what is resistor voltage? Resistor voltage is 5 minus diode voltage, 5 is fixed. So, diode voltage is, so listen very carefully, this is restriction which diode wants to put on ID and VD. And what is this? This is the restriction which resistance wants to put on voltage across resistor and current through resistor, but current through resistor is current through diode, and voltage across resistor is 5 minus voltage across diode. So, ultimately resistor also wants restriction requirement to be fulfilled between VD and ID. So, this is one equation, linear equation between VD and ID governed by the resistor. This is non-linear equation between VD and ID governed by the diode, and they intersect at a point. So, this is the answer. This would be the final VD and ID, which will be the answer. So, this is voltage and this will be the current. Now, if you either increase voltage, this will shift on the other side. If you decrease resistance, it will shift on the other side, this side. If you increase resistance, sorry, if you decrease resistance, it will go on this side. If you increase resistance, means if this point will move on this side, if this point will move on this side if R is increased and V is reduced, and this point will move on this side if reverse effect, R is decreased and V is increased. This point will move on this side if V voltage source V is increased, and on the other side if V is increased, like this. So, this point and this both points will change depending upon voltage source V and resistance R, and that will make the point like this. If this R is too large, we started with, if R is too large tending towards infinity, it will come here. So, if I draw an exaggerated graph, what I will find, if R is too large, I just draw somewhat not to the scale like this, and if R is too large, then it will meet here, somewhere here. So, voltage across will be very small. If R is going to infinity, it will become near 0. So, if for an ideal voltmeter, if I connect 1 volt, 1.5 volt cell here, I connect this here, and if I connect a voltmeter, if the voltmeter is ideal, this voltmeter should read 1.5 volts because voltmeter draws no current. If even digital voltmeter is having very high input impedance, but if it draws some negligible current, then it should read something like 1.4849 volts or so. So, the concept of this eating 0.7 is irrelevant. If you connect some load here, then as current it eats, if it is having opportunity, current starts flowing. If you connect a resistance, means actually I do not know why this experiment in pedagogy, actually what should be told. You can now simulate using protease. So, what you should have, there should be an experiment, a diode, a circuit is put 1.5 volts, a simple battery cell, and simply you can have multiple combinations. 4 is I think enough. I think even 3 would have sufficed, and voltmeter. right, 1.5 volts, a diode here and this voltage. When all are off, and this you can have maybe 100 ohm, 200, something we can have, their parallel combinations, 200 ohm, 500 ohm and 1 kilo ohm, like that you can have, or not 1 kilo is too small, maybe 100K, 50K, 20K and 10K, or 5K, 10K, 20K or 50K and 100K. So, that you can have various combinations. If you have that, and then when all are off, note down, when all are off, what is voltage? When this is on, what is voltage? When this is off and this is on, what is voltage? So, you can have resistance RL infinite, VO, voltage of the voltmeter reading, VO. Then RL 100K, RL 50K, then you can have their parallel combination, it will be having some 33K, then you can put both off. So, there will be 16 combinations and there will be 16 values and they will be reading. So, that will tell diode load line how it should be conducted in a simple manner. Unfortunately, I do not know why such kind of chassis is not designed. Using protests you can have it. So, when the resistance is there, then sufficient current flows and 0.7 is eaten up by the diode. If sufficient current is there, if sufficient current is not there, it can't eat 0.7. So, a logic that something you connect on left hand side, you connect a diode and at the output there will be 0.7 less is wrong. So, what is needed is, according to me, for every electronics engineering student, understanding of this fundamental concept of diode is very important, and unless that is built up very properly, we cannot proceed. Using this now, we will be explaining how transistor works, because working of transistor by using two junctions, one junction is forward bias, one in reverse bias, is simply beyond understanding. We will also provide very simple modeling of transistor in the next lecture. I think this is an attempt to make all the colleagues aware about the requirements from students' point of view of pedagogical techniques. I think it is enough for today. We can stop.